Let's say you're trying to buy an ice cream and the ice cream has two flavors. You can either choose chocolate. Let me actually use brown when I'm drawing chocolate. So let's use this. So you can have a chocolate ice cream or you can have a strawberry ice cream. You only have two choices in this store, let's say. And for the cone, you have three types of cones. You have black cone, which is very interesting. I guess it's a new type that the store invented. So you have black cone, you have blue cone, which also looks very exciting. So you have blue cone. If I can draw it not as slanted, yes. Let's go with this. Blue cone, and you also have a green cone as always. So you have three types of cones and two types of ice cream. And I'm going to ask you, you can select only one of the type of ice cream, only one type of ice cream, and you can only select one cone. How many ice creams? How many ice creams can you make? How many ice creams are possible? How many ice creams are possible? And you may say, well, there's two ways. There's two ways to choose the type that you're going to pick, and there's three ways to choose the cone. So maybe it's 2 plus 3, maybe it's 2 times 3, maybe it's that's not getting us anywhere. Let's try to simplify this by using logic and common sense. Well, let's say you pick a chocolate. So let me draw it like this. There are three ways that you can pick the remaining cone. You can either pick black one, or you can pick the blue one, or you can pick a red one. So you have these three different choices just for the chocolate. And if you pick strawberry to begin with, you can pick a black cone, you can pick a blue cone, and you can pick a red cone. Oh, no, it was not red cone. I was like, I don't think we had red. I meant green cone, but the logic is still the same. So in this case, it's obvious that we have 2 times 3 choices, or 6 choices, because you have 3 sets of 2 choices. That's 2 times 3. Another way of visualizing this is by drawing a tree diagram. So let's say you can begin with a chocolate, or you can begin with a strawberry. Once you begin with a chocolate, there's 3 ways to go. You can either pick a black cone, or a blue cone, or a green cone, and the same reasoning applies once I can draw this, if my pen starts to work, or green cone. And we have the same 3 choices for strawberry. You can either pick black cone, or blue cone, or green cone. And it's obvious that in this case we have 3 sets of 2, so we have 3 times 2, or 6 choices. And this thing is guiding us toward a very important principle in counting, or multiplication principle. It's basically telling you that if you have, let's say, x sub 1 choices for the first category and x sub 2 choices for the second category, the number of total categories possible by picking one from the first category and picking one item from the second category, you just multiply them up, x sub 1 times x sub 2. So that's multiplication principle. So let's try one more thing. Let's say you have 2 different math classes you can take. You can either take algebra 1 or geometry, let's say. And you have 3 different science classes you can take, biology, chemistry, or physics. And you have, let's say, 2 other electives that you can take. So how many ways can you choose your classes? Well, you can have 2 for math, 3 for science, and 2 for electives. And using multiplication principle, you're going to multiply them up, getting you 12 choices. So we have 12 ways to pick our classes, such that we're taking 1 math class, 1 science class, and 1 elective class.